Lesson 4.3, we start talking about the unit circle. So the circle you just put past the page in your notes, that's the unit circle. It's the circle graph on the sideboard in my room, right? That's the unit circle. Okay? With the unit circle, let's talk about a little vocabulary first of all. Okay? First, just when looking at any given angle as we work with the unit circle. Okay? Vocabulary of initial side and terminal side. Initial side being the side you are beginning at. Okay, so starting your measure at. Terminal side being the side that you are ending at. Okay, so as we go to measure an angle, they might talk about the terminal side. That's your ending point, essentially. Now, I mentioned last week a little bit about that unit circle. And I'm trying to remember, yeah, if you look at the unit circle in your notes, you will clearly see a 0 degrees, okay? 0 degrees is the x-axis off to the right. That's 0 degrees, that's 0 radians, okay? That's always where we start our measurements when we're working with the unit circle, okay? So when I talk about starting your measurement at 3 o'clock, that's 3 o'clock on the clock, right? So that is your 0 when working with the unit circle. The unit circle, we are always going to measure counterclockwise when going in a positive direction. So counterclockwise going the opposite way of the clock, right? So you're going backwards. And so right here, for example, it's blue on my paper, but this blue angle here has a measure of A because it's starting at 0 degrees and it's going counterclockwise. So that's where you would measure A. Okay, and that would be your positive angle. So if I had to guesstimate, I don't know, maybe that's 120 degrees or so, right? Because if here's 0, straight up would be 90. So you're going past 90, I don't know, 120 degrees-ish, something like that. Now, that's a positive angle. Okay, we can also measure negative angles on the unit circle. And negative angles go the other way. Okay, so a positive angle, your positive direction is to go counterclockwise. Now, a negative angle is going to go clockwise. So a negative angle would be starting still at 0, so this is still 0 degrees, 0 radians, and now going clockwise. So going down the clock, when you go clockwise, this is a negative angle. So if we go, and this would be angle beta, that's a capital B, a beta. So if we go and measure this, now, like right here, if I'd be at this farthest down point, that would be negative 90, because we're going negative. As we come over here, that's negative 180, and you would end up past negative 180, maybe negative 190 or so. So that would be a negative angle because we went clockwise. I almost want to say backwards, but if I throw out the word backwards, that's going to confuse the issue. But we went clockwise. So positive angles, you're going counterclockwise. Negative angles go clockwise, and we'll work with that lots. Okay, but there's the reference information in your notes. Now, the vocabulary we're first going to work with are finding coterminal angles. Okay, coterminal angles are those that start at the same initial side and they end at the same terminal side. They simply swing around the center more than once. Maybe they go the other direction around the center. Maybe they go 2 times around the center. Okay, so the idea as we talk about coterminal angles, while it can be one angle showing, it can have lots of names for it. Based on, did you go in the positive direction to get there? Did you go in the negative direction to get there? Okay, so coterminal angles, they start at the same side, they end at the same side. They just may take a different route getting there. Okay, so some examples of coterminal angles. 90, 450, and negative 270 degrees are all supposedly the same angle. Now, we can just believe it because they tell us, or we can kind of dig into it a little bit. Okay, 90 degrees. What's 90 degrees look like, guys?
Right angle.
Right angle. And if we're talking 90 degrees on the unit circle, there's your 0, yes. Where's 90 going to end up? 90 is going to end up going straight up, yes? Because how would we get from here to here? That would be 90 degrees. Does that make sense? Now, so that angle is 90 degrees. Supposedly, that is also 450 degrees as well. So think this through with me, okay? We still start here at 0, yes? Okay, this is always 0, our starting point. Okay, so right here, if I'm at here, I'm at 90, yes? What am I at if I'm at right there? 180. Keep going. What am I at when I'm at the straight down point? What's 180 plus another 90? 270. Keep going. Now I'm back at my beginning point. What is this? 360. Where am I at if I go one more 90 degrees? What's 360 plus another 90? 450, yes? Have I kind of convinced you that 90 and 450 are the same thing? Okay. The key is 90 and 450 are how much apart if we subtract them? They are 360 apart. Okay, so it's a difference of going a quarter of the circle or a whole circle plus a quarter of the circle. So that is your 450. Now, supposedly negative 270 is the same. Okay. Where's negative 270 going to take me? We still start at 0, but negative tells me instead of going back and around to the left, we're going to go down and around. So we're going to follow this way. So now, okay, where am I at if I stop right there? I went clockwise, so that's negative, and that's negative 90, yes? Okay, what about if we get horizontal here? Now I'm going to be negative 180. And what do we end up with over here? Negative 270. Because 270, I think you can agree, is 3/4 of the way around the circle, right? It's halfway between 180 and 360. And so it's going the other way around. So 90, 450, and negative 270 are all names for that right angle. Are we okay and that's super easy, or are we not okay and we're confused? Or we're not even sure yet? Okay. Tell me if you're confused. Tell me if I need to try and explain it differently. Because I never know. Okay. So those are examples of coterminal angles. If you do the math and start looking, 90 plus 360 is 450. 90 minus 360 is negative 270. So they're a difference of a loop around the circle, which is 360. Now, we have to work in radians too. That's going to be the harder part of this chapter, but we have to work in radians too. The argument here is that pi, 3 pi, and negative 99 pi are all the same angle. Now, what do you know about pi? We've talked about pi. Pi is the same as 180 degrees, yes? If you go back, you have that unit circle you can on the page before, yes? There's your reference to help you get familiar with this. Pi is at 180, yes? So, There's my 0 to get me started, right? And then when we talk about pi, it is basically 180 degrees. Okay. Now, so pi is halfway around the circle, yes? What about 3 pi? Supposedly it's the same. What's 3 pi going to do? It's positive, so again, we're going the same direction, yes? Okay, so we're going counterclockwise. Right here I'm at 1 pi because I'm going halfway around the circle. Now, what happens when I continue this and go the other halfway around the circle? Now I'm at 2 pi because I went another halfway around the circle, yes? What happens when we go another halfway around the circle? Now I'm at 3 pi. Is that the same piece? Yeah. We're back, officially it's pi, but going 1.5 times around the circle is 3 pi. Okay, so good to know. Pi is halfway around the circle, yes? What's another name for 0? Another name for 0 is 2 pi. Okay, kind of like another name for 0 is 360. Okay, so there is your 3 pi. Now, how adventurous do you feel? Negative 99 pi? You want to draw that one out with me? No. That's good, because I'm not going to draw it out either. Think logically. Okay, if we just start looking at this to begin with. Okay, here's 0. Negative means we're going to have to go the other way, yes? So if I start here at 0, and the first thing I do, and I'm not going to draw this all the way out, but where am I at right here? This is, I went halfway around, but in the negative direction, so this is negative pi, negative 1 pi. Well, what happens if I go again over here? Now I'm at negative 2 pi. What am I going to be when I get back here on the left? Negative 3 pi. What's going to end up happening? We keep going, we're going to be at negative 4 pi on the right, negative 5 pi on the left. What's coming out on the left? All of my odds, yes? So is negative 99 pi going to make sense? Yeah, because halfway around the circle is 1 pi, and so each time you're going to hit your odds over here on the left. You can also think of it going the same, going in the positive direction. It'd work out the same way. You'd have odds on the left, evens on the right. Now, while my degrees were all separated by 360, 90 plus 360 is 450, or 90 minus 360 is negative 270. What are these pi's separated by? Pi plus what is 3 pi? Pi plus 2 pi. Okay, so in other words, what's one lap around the circle? It's 360 degrees, or it's 2 pi radians. Okay, and that's what it talks about down here. These angles simply differ by an integer multiple of either 360 degrees or 2 pi radians. And that's because once around the circle is 360 degrees or 2 pi radians. Okay. Questions there? I'm not sure if we're there or not there. Maybe we are, maybe we are. I think it depends on the person too. Okay, should we look at example 1? Let's see what we can do with example 1. And I'm going to make you do it on a circle or anything. They're asking you to find 2 answers. A positive angle that is coterminal with the given angle and a negative angle that is coterminal with the given angle. Okay, remember, coterminal angles are those that start at the same initial side, they end at the same terminal side, they simply swing around the center more than once. Or they could go the opposite direction. So, 30 degrees. We want to find a positive coterminal angle for 30 degrees. How am I going to find a positive coterminal angle for 30 degrees?
You just add 360.
Okay, does that make sense? Because 30 degrees, we would just go straight there. Yes, it's a little small angle. But if we want another positive name for that, that means you would, from 30, go around a whole nother loop. And so you're going to say 30 degrees plus 360 degrees is 390 degrees. Okay. We also need another negative. We need a negative angle.
Yeah. Subtract 360.
Okay, here's the deal. These angles are 360 degrees apart, right? Whether you're going in the positive direction or whether you're going in the negative direction. Okay, so I mean, if you do 390 minus 360, you're back at 30. But then if you take 30 and subtract 360, what is 30 minus 360? Negative 330 degrees. Okay. So the argument is that 30 degrees, 390 degrees, and negative 330 are all the same angle. Could you give me more coterminal angles? Are those the only right answers? No. You want another positive one? Add 360 again. Add 360 another time. We can go, you can give me lots of ones. Okay, you can get fancy here. Okay. So what about B? Negative 150 degrees. I want coterminal angles there. A positive one and a negative one. What am I going to do? Same thing. What happens if I take negative 150 and I add 360 degrees?
We'll get 210.
210 degrees. Okay? 210 degrees is another name for negative 150. What about negative coterminal angle? You're going to subtract. You're going to go back to your original negative 150 and subtract 360 degrees. Negative 150 minus 360 is negative 510 degrees. Okay. Your answers should all be multiples of 360 apart. If I take 210 and I subtract 360 and then subtract 360 again, I should get to negative 510. Okay, so coterminal angles, you're adding or subtracting 360. Until we get to part C. Okay, what changes up in part C? They're going to make us talk radians. Okay? 2 pi over 3 radians.
Add 2 pi radians.
Okay? If it's degrees, we were adding 360 degrees, yes? What's equivalent to 360 degrees in radians? Once around the circle is 2 pi. So you're adding 2 pi. So 2 pi over 3 plus 2 pi. How do I add 2 pi to 2 pi over 3? Or forget the pi's. How do I add 2/3 to 2?
2 2/3 usually.
Okay. You could say 2 2/3.
4/3.
Okay. I disagree with 4/3. I'm not sure where that's coming into play.
Oh, wait, no.
Okay. And here's what I would say. In order to add 2/3, and I'm going to take a slightly different route. I agree. 2/3 and 2 is 2 2/3. Make it improper. That works. Also, what is 2 as a fraction? It's 2 over 1. What would a common denominator be? We'd have to have a denominator of 3. And what is 2 when we start talking about 3? That's going to be 6/3.
Yeah.
So could you just add 6 pi over 3?
Yeah.
What's 2 pi over 3 plus 6 pi over 3?
8 over 3.
8 pi over 3. Okay. Now, that's a positive coterminal. What else do I have to do? Find a negative coterminal. How are you finding a negative coterminal? You are subtracting 2 pi. How am I going to subtract 2 pi?
6 pi over 3.
Okay. This time you're going to subtract 6 pi over 3. What is 2 pi over 3 minus 6 pi over 3?
Negative 4 pi over 3.
Negative 4 pi over 3. Okay. So those are coterminal angles. Okay. That's vocabulary you'll have to be familiar with. As we start to work with radians more, folks, you have to be able to work with fractions to work with radians. Okay? Just being able to do something like 2 pi plus 2 pi over 3. We've got to review, those basic fraction skills that they're there in your heads. You just got to use them. So, okay? Tomorrow, we'll start off talking about reference angles and what exactly reference angles mean. But for today, this is a good point to stop because we're not really going to get into reference angles. So reference angles carry in through all that we do in the upcoming.